So, OCCIware, as has just been said, is an extensible and standard-based XaaS, everything as a service platform to manage about everything in the clouds. And it's what I'm gonna talk to you about. First, a short introduction, then about OCCI, the OCCI standard, but also about OCCIware, the OCCIware product. Then I'm going to introduce a real-world use case to make things interesting in the field of smart city by trying to bring the power of big linked open data analytics to help monitor energy consumption. Very important field in this era of climate change. And I'm gonna do, a quick demo, hoping that it's not gonna go haywire. Show you live the OCCIware Docker Studio. Obviously the OCCI Studio itself, Metamodel, and the custom developed linked data extension for the specific field business domain of smart city. Before concluding about what will be coming up next for OCCIware, a lot of exciting things, obviously. So, OCCIware, why OCCI, why OCCIware? There is a problem in the field of cloud computing. Okay, I think everybody here may have a different opinion about that. That depends on what you mean, on what you think cloud means. Cloud can mean a lot of things for different people. It can mean infrastructure, it can mean platform, it can mean application. It can have meanings in very specific niche fields, in software fields. But if you get the big picture, there are a lot of answers to the cloud computing problems, but there are maybe too many answers. And that's the problem. At infrastructure level, you have standards, but you have too many of them. And the main one, the most used one, Amazon AWS API, is not even an official standard. At platform level, where you have no official standard, and you have a lot of APIs by each and every provider. I don't know, Cloud Foundry, OpenShift, and all PaaS technologies. This morning we're talking about Kubernetes. And at the application level, well, it's even worse. You're up for yourself trying to create the glue for everything to work together. It's a free-for-all. We are in dire straits here. So the point of OCCI is to try to provide a unified view over all that, a very simple one at that. Here's a little primer about the Open Cloud Computing Interface, which has been designed by the OCCI Working Group within the Open Grid Forum and has been working in production for several years. In OCCI, everything is either a resource or a link. For instance, at infrastructure level, you can have compute resources, that's virtual machines, and storage resources, that's disks. And if you want to mount a disk onto your VM, well, you just have to create a link that links the storage to your compute, where it's going to be available. And it's the same at platform level with containers, databases, and database link to provide a database to your application. At application level and even at business configuration level. For instance, if you have multi-tenant software, multi-tenant cloud application, when you get a new enterprise consumer, a new enterprise customer, sorry, well, you usually don't only have to provide the infrastructure and software resources to him, but also to configure his account with, for instance, the billing information, very important for you to survive as a company. So that's OCCI. So, great, fine, if it works in production, why OCCIware? Why do we need anything else? Well, because standard is great, but if you want adoption, and if you want such Metamodel to scale up, an extension being built for it, because the whole point of it is that you've got it, it's extensible. You can add your own attributes at infrastructure level. For instance, you can provide SSD or SATA disks, or you can design a whole new extension for a whole new layer that is your own business domain layer. Well, if you want to be able to do all that you yourself, that is only a cloud application provider, that don't want to be a cloud provider all the way down to infrastructure level, you have to have tools. You have to have a platform. You have to have the execution platform that makes it all work top to bottom. So that's OCCIware. The OCCIware product is first the OCCIware Studio, which is based on Eclipse and allows to visually design, verify, simulate, and develop everything as a service. And an execution platform, let's say OCCIware Runtime, which allows to deploy, execute, manage everything as a service, which works thanks to erocci and Java. Erocci, which will be presented in next talk. My eyes go to the right. Good luck, John. A few facts about OCCIware. We are now at middle point in the duration of this public-sponsored project, and its ambition is to lower cloud computing adoption costs by breaking up barrier between the various cloud implementations, cloud layers, and cloud domains, and especially in a few fields which are data center, obviously, infrastructure, deployment, big data, and linked data also. Thanks to OCCI, obviously, but also the power of formal languages and model-driven engineering. So ambition doesn't stop at infrastructure level. It doesn't stop at platform level. It doesn't stop at analytics, big data level, neither even at linked data. That's you who are going to define where it's going to end. It's a cloud consumer platform. Cloud provider platform, there are a lot of them. This one is for you. It's a cloud consumer platform. Yeah, we have a Metamodel that is extensible. That means that not only the model is extensible, the tooling is extensible. And you can design your own studio along near the Docker Studio at infrastructure level, the Roboconf Studio at PaaS level, and obviously the Meta OCCI Studio. So our use case is about monitoring energy consumption, not only per user, well, per consumer, as you can find on your own energy billing each month, but also per city, per country, because we are trying to find out energy leaks in the whole climate changes picture. That means having a multi-point of view over data. That's linked data, because that's the answer for such an open world approach that it requires. We use what's called the OCCIware Data Core. That's a component that provides a REST API for linked data, that it's both web-friendly by being JSON and also semantic web compatible by being JSON LD, thanks W3C for the standard. We have developer with this playground, which is, we also have a Swagger playground, obviously, but Swagger is a little too technical. You know, Swagger is for developers, and at some point, developers, technical developers become business developers and need to be able to have, well, I don't know, like an SQL client, a REPL shell. That's what this is, a functional playground to help you debugging queries, etc., etc. So how are we going to get some help from OCCIware? Very easy. Here is the design. We have our linked data core here, which is Java over the Mongo cassette. All of that is Dockerized in a VM. And We have a few cloud configuration domains, which are project governance, which are filling in the energy consumption data from sensors that are in consumer homes, your home, and getting them back and treating them to be analyzed and getting information about aggregated consumption for a given consumer or a whole city. And here actually we need to be very efficient. Being very efficient means being able to disable robustness. It would be too costly. And to aggregate stuff means to rather work on a copy of data and not even primary data, because otherwise, well, what happens is that you are going to hamper performance of the main data collaboration use of our linked data core. So we have here to tap on the Mongo secondary. And that's cloud configuration. You know, we not only need to provide infrastructure, these Docker containers, we also have to provide the software over it, the Java software. And we have to configure it so that here we don't have robustness, and here it taps on the secondary, not the primary, as the standard regular use case. And here we have some other stuff like governance. I was talking about multi-tenancy beforehand. A quick demo. So here is the linked data extension. You can see that everything inherits from entity and is either a link or resource. I didn't lie. And we have our business-specific domain, which is linked data project, which manages configuration per dataset, and linked database link, which will allow us to specify a given infrastructure node for project to tap in. You can have also other views, such as DSL, which says exactly the same stuff. You can see here we have an attribute, which is whether we have robustness or not in this project. We have an action, publish or unpublish, those are governance actions. We can have checking, model checking, formal checking, where generate runtime execution platform configuration, do a lot of stuff. I don't have the time to show you all that. But here is the tooling, the visual tooling, first at infrastructure level. Here we have a local virtual machine. Here we have a remote virtual machine provided by OW2, thanks to OW2 and OpenStack. And we have Docker container in it. Okay, a lot of people are allowed to visually configure Docker containers. But this one is even more interesting because it allows you to, yeah, everything is started. It allows you to configure also the other layers. And the other layers here means configuring various projects about geographical elements, about organizations, enterprises, companies, and to specify that we have a different view over data that is analytics specialized, and that allows us to specify using an LD database link which infrastructure node we are gonna tap data from. And here it's OCCIware Mongo 2, which is here. And I can do various stuff. For instance, I can start, publish, unpublish. For instance, here it's not published. I can publish it. It's going to be published here. And if I go here in the playground, it should be published. So here, it was not published, nothing was frozen, and now here it is frozen, everything is frozen, so it's published, nobody can change it anymore, it's available for production use. So here we are. You can see how we can manage at once every layer in the cloud, which allows, in our case, not to hamper the main use case of data collaboration performance when aggregating energy consumption and saving the world from climate change. Results are shown here, aggregation by consumers, aggregation by city, other cities, other countries, territories, thanks Spark in between, and Spring Boot microservices. What's upcoming? A lot of stuff, more. I enjoy you to get a look at the functional playground, not of the data core, but of OCCI. And I think you're going to have maybe an insight when Jean will be demoing the erocci runtime just after me. Thank you very much for your attention.